Good evening. My name is Cara McCarty. I'm the Curatorial Director here at Cooper Hewitt, and I'm delighted to see all of you here this evening. It's given me a great opportunity. Pulling together my thoughts for this talk tonight has given me a really nice opportunity to rethink this marvelous collection that George Kravis recently gave to Cooper Hewitt. And tonight's talk is really very much a celebration of this magnificent gift that we acquired, that we are in also will be acquiring some more pieces, and I think many of you have just had the opportunity to see it on the museum's second floor. Energizing the Everyday is on view here through March 12th before we take it down. So if you've not had a chance to see it, I highly recommend you go up, have a look at it, and bring your friends. As I was preparing for the talk, I was walking through, and I must say I felt a lot of joy looking at many of the pieces. Many of the works were designed over a 100-year period, and it was a period of great optimism in the United States and American design looking towards the future. And I think just about every object in the show is just, to me, is so exuberant and exudes optimism. It also is very much a personal collection from George Kravis. George started in the broadcast business. He was very interested in radios, televisions, broadcasting, and in fact, when he started collecting as a young boy, he said anything that has a plug, cord, battery, or a motor was of interest to him. And so those were his, at least his initial collecting criteria, and I think if you see the exhibition, you'll certainly see that. And you'll see a number of those examples in tonight's presentation. It's also, George's collection it's so ideal for Cooper Hewitt, and any museum like this would be so overjoyed to receive it. It dovetails beautifully with the collecting philosophy of Cooper Hewitt, our focus on industrial design, and many of his works really filled some gaps we had in our collection, so we could not have been more overjoyed when he approached us about wanting to give it to him. So I know George is sitting in Tulsa, Oklahoma, so I'd like to give him a shout out here from Cooper Hewitt and thank him very much. Okay, so we will start this first slide. As I said, the collection, George's collection spans about the last 100 years, but I'd like to step back a little bit further back in time just to put his collection in context with what was happening in the world, and what was happening in the world as we move towards a modern world, and what is a modern world. So this first image here is of a map, 1854 in London. In fact, these first few slides are about what was happening in London, which was many considered to be the first modern city. This map was taken, I actually took it from a book I read recently or a few years ago, which was really changed some of my thinking or pulled together a lot of my thinking about the 20th century. And it's called, I need to look at this because it's got a very long title. It's by Stephen Johnson, called The Ghost Map, The Story of London's Most Terrifying Epidemic and How It Changed Science, Cities, and the Modern World. If you haven't read it, it's a great read, and I highly recommend it. So this starts out, this first image is a map, 1854 London, and it's Dr. John Snow's map of the deaths in London from the cholera epidemic. And what's so significant about this is it was really the first time that they applied science to analyzing health. Germs were still sort of a mystery. The spread of disease, cholera was thought to be spread by miasma, but Dr. Snow started applying scientific principles, a method of scientific investigation, to these deaths. And he started to chart the deaths on this map. And lo and behold, you can see these sort of darker splotches. These are the areas where the deaths were occurring. So it's not that it was so much out there in the air just wherever you went, but it happened to be in a certain location in London. And this is a time when they also discovered the cholera bacterium. And they learned that cholera was actually coming not from the air, but from the water system, from the polluted water system, from certain pipes. And this led to the engineering of a wastewater system. So a grand, colossal system, brand new, but it was underground. So it was not something, it was a design feat, but it was not something that was readily visible to the residents. Also at the same time, that was highly visible, was a 1851 Crystal Palace Great Exhibition in London. This was the largest building that had ever been constructed to that point, and it was really a celebration, a global celebration of design and manufacturing feats, design feats from many countries in the world. It was a temporary pavilion, but it was a grand statement and was a very intentionally visible celebration of grandiosity and human ingenuity. Concurrent with this, in 1863, was the first underground system in the world that started in East London. And this is also very important because it was dealing, like the other two, with large number of people and dealing with how the complexities of so many people living together, and in this case of the underground, how do you move large numbers of people quickly without interruption? And so this is a map from 1907, but still it gives you the sense of the major network of the London Underground, which still pertains today. And in fact, and let me just tell you, there is the fourth factor, which is not a design, a physical design manifestation, but it was a sort of an economic intervention, and it was the beginning of the mortgage system, which still exists today, and it enabled people, the middle class, to have homes. And that's very important because what started to happen at this time, it was the beginning of the mass production of products that could fill people's homes. So this was, collectively, these four moments, these four happenings were really, became very much a defining part of the modern city going forward. A lot of tonight's talk, as was in the description, is very much about science, technology, materials, and innovation. So while those phenomena were happening up in London, down in Germany, the industrialist Michael Tonnet was trying to figure out how to mass produce furniture. Of course, with the rise of the modern city, we have the rise of the cafes, we have the rise of social networks, people congregating together, and what type of furniture do you create that you can put in these spaces, that you can move, that's lightweight, and that can be done rather quickly. So in the mid-1850s, Michael Tonnet came up with a method of mass producing furniture. And he did this by finding ways to greatly simplify furniture production, reducing the number of parts, reducing the ornament. Up till now, a lot of the furniture had a lot of ornamentation on it, carving, painting, elaborate upholstery. And he found a way to mass produce furniture by bending solid rods of wood around iron forms, so that then they were steam bent rods, and they could be the same length and bent around these forms, so that he would come up with, create modular units that in many cases could be mixed and matched to form different types of furniture. As you can see in this cube, you see the replication of many of the same parts. What was also important about Michael Tonnett is that he anticipated all the needs of a modern manufacturer. He's had a mail order catalog, and his furniture was designed to be knocked down and shipped all around the world. This is a broadsheet from the Tonnett catalog in 1859, and you can already see between 1853, when he perfected the process of bending identical rods of wood, to 1859, he created this many versions, and every year there were more and more variations. Now, one of the materials I should say that I want to follow through tonight, and I've picked just a few materials to really follow through. This first one, of course, is wood. Wood is a material that is a very old material. It's a traditional material that we associate with furniture, housing, many of our products. But like many materials, human beings have continued to find ways to innovate them, find new applications, find ways to change their forms. And another important designer named Alvar Aalto, working up in Finland, an architect, was creating new modern architecture in the late 1920s, 30s, 40s, up through the 60s. And of course, like many modern architects, he wanted to create a furniture that was specific for his architecture. And as you know, a lot of the modern architecture started to make use of large glass panes, so there was a much greater flow of interior space, inside, outside space. So wouldn't it be appropriate to have transparent furniture in those spaces that were not blocking these wonderful flowing vistas? So Alvar Aalto took Tonnett's idea of bending furniture around molds even further. He bent not only solid rods of wood, but also wide sheets of plywood. And just to give you an idea of the type of experiments, during a 4-year period, Aalto and the people he was working with in the furniture company came up with several key experiments that provided the forms and the innovations for the furniture that he designed and used for the rest of his career. So you can see in this slide how he was experimenting with splitting wood, and then he would insert little thin sheets of wood, glued wood, and then they could bend that around a form so that it was much easier to bend a solid length of wood. Again, playing with the nature of the materials itself. And here's a closer look at the way Aalto, Aalto's furniture manufacturers were bending wood. As you can see, we often talk about mass production, but I would argue, by and large, a lot of it still is not mass-produced. There's still a lot of hand intervention, and that's what often has happened, this wonderful marriage of the hand and the machine, and you'll see that throughout tonight's talk. You can see, this is just amazing feats, bending around molds, clamping the furniture to achieve the desired shapes. But again, you can see splayed out on the walls the repetition of the modular shapes that Aalto would design that could be used for stools, it could be used for tables, it could be used for high chairs. In 1940, the Museum of Modern Art had several furniture competitions or lighting competitions, design competitions, and their first in 1940 was home design, organic designs for home furnishings. And the designer Charles Eames and Eero Saarinen partnered up to submit this chair design, which won the first prize. And as you'll see, again, if you look at the back, it looks like molded plywood. Again, to simplify the number of parts that went into the production of a chair. And then a very, very thin, rather than a heavily cushioned upholstery. This chair, it looks like, and I'm delighted to have this in the collection because it really extends the museum's ability to really explore the notion of bent wood furniture. They weren't quite able to achieve this seat and back in one continuous piece, so where the back meets the seat, there is a very, very discreet seam. But it anticipated, like for a lot of designers, like we just saw with Alto, this anticipated this, a lot of Eames's work going forward. Then, of course, the war came, and during the war, a lot of designers were enlisted to help with a lot of the innovations, the design of new products for wartime use. Charles and his new wife, Ray Eames, partnered together. Then they continued their explorations of bent wood. This is a leg splint designed in 1942. Up until then, the leg splints were made of metal. They were actually very uncomfortable for the wounded. They also were leading to infections. And so the Eameses came up with this sort of one-size-fits-all mold. It was molded that could be mass-produced, and it is strengthened in a few parts to give it more durability. The holes were also enabled places to tie straps to secure it to the body parts. Also during this time, the Eameses were, with their wood-bending experiments, they designed this nose cone for a glider, also during for potential military applications. It never went into use, but still it demonstrates how wide-ranging their interests were. After the war, in fact, the war provided many opportunities for many designers to really innovate and apply their ingenuity. After the war, many of the lessons that the Eameses learned, they continued to pursue. This is a chair, an bentwood chair that Ray and Charles Eames designed. And again, it's contoured, so it's more complicated even than Alto's chair, but now imposing complex curves into this piece of furniture, which is still manufactured today. And I would say that the Eameses were so enlightened in the way they and the exuberance at which they experimented with all the new materials at the time, not only wood bending techniques, but fiberglass, aluminum, foams, that they really pioneered a lot of the designs that many other designers have made entire careers out of. They also experimented with radios, and I'm so delighted that George acquired these because they're exceedingly rare. But it's, again, in this example, the use of bent wood, of course, to find ways to mass produce radios, and it's different from a carved piece of wood, which would have been more time consuming, but it's also addressing the notion of making an object that appeals to the modern interior, that fits in the modern interior, because always with new products, new types of products, the thinking is, well, what should they look like? Often there's a lot of freedom for the designer to determine what something should really look like. And here they wanted to try to make it fit within interiors. Fast forward, because wood continues to be innovated by many, many designers, and it's so desirable to many people because of its warmth and because of the possibilities for many, many different types of shapes. This was designed by a Danish designer, Mathias Bengtsson, in 1999 when he was a student at the Royal College of Art. And it looks to me like a three-dimensional topographic map. Again, he started out with a clay model that he modeled with his hands, and then it was analyzed and sort of taken apart by a computer in these very, very, very thin slices. You can see all the strata in the chair. And then he had a laser cutter cut through the wood so that every layer of it was a separate piece of wood. And then Bengtsson went out in afterwards and created this wonderfully sculpted chair. So we'll move on to the next material that really, if I asked you to say what material or a couple materials do you associate mostly with the 20th and 21st century, I wonder what you would say. But when I asked myself that question and I was looking at this, I said aluminum and plastic. So those are the next two materials that we will look at. And why am I showing you this photo of the Washington Monument that was completed in 1884? Sorry. I was hoping you were one. I was piquing your curiosity. Standing here like an exclamation mark. I was really pleasantly surprised to read that the top 9 inches of the Washington Monument is made of aluminum. And why is that? At the time, aluminum was still an exotic, rare material, but it was chosen for this because of its sheen. It was rust resistant, but also because of its conductivity. And it was used, it was a lightning rod. And prior to this, usually copper was used or bronze was used for these purposes, but aluminum being a brand new material, the engineers thought, well, and also because it might absorb the shock of lightning bolt. In 1840, the scientists found a way to extract aluminum from the Earth's crust. And it was really an intellectual exercise. They were not trying to extract aluminum for particular use, but it was really more of a challenge and intellectual pursuit. They succeeded, and then the next period of time, almost till the end of the 19th century, engineers and scientists worked on ways to extract it much more easily, to process it, and so that it could also be much more readily available. When they first started to find ways to use it for products, aluminum was as expensive as silver, which was very expensive at the time, and it was used for luxury items like opera glasses or jewelry and other such things. But by the end of the 19th century, they were able to mass produce it, and so the next period of time, manufacturers came in and started finding applications. One of the first applications was kitchenware, and it was rather inexpensive at the time, rather cheap at the time. It was a brand new material, and it was a bit of a hard sell. So the people who were really trying to promote it were the manufacturers themselves. They wanted to find applications, and so when they were exhibiting at these World's Fairs. And during this next period of time, I would say up until about 1920, as aluminum was starting to become more favorable to the public, there was also a real transition in the woman's role in society, and the woman's role particularly in the house. And there were fewer servants at the time, and so women were starting to take on more household responsibilities, and also looking for products that would help ease her labor, her work. There was also the whole health was a big concern, and there was also the gene theory, germ theory. I'm talking about 21st century gene theory, germ theory, when they thought that people were very concerned that germs were transported by dust and dirt. And so the housewife was really starting to model their kitchens in a much after sort of the scientist way of organizing their laboratory and keeping very clean environments. One of the designers who started working with aluminum and its wonderful properties of lightweight, that was the primary lure of aluminum, is that it was lightweight. And when they could work it, it was also very malleable. It didn't stain. And so at Russell Wright, the designer Russell Wright, started working with spun aluminum. In fact, he formed his own company. And at this time also, there was the rise of the home entertainment. As the middle class started to have more homes, the housewife had a bit more time. And then at this time, there was also the Depression. And so manufacturers were looking for ways to promote some of these materials, but people were starting to do more entertainment at home. And so Russell Wright came up with a whole range of these wonderful sort of serving sets, taking them out of the kitchen but to the living room. So cocktail serving sets, there were bun warmers, celery trays, punch bowl, this is punch server. And then they would warm it with these little touches of wood or cork or rattan that were not only sort of decorative elements, but they were also for insulation to keep one's hand from the, insulating it from the heat. Now here we are introducing electricity. Of course, at this time, paralleling what I was mentioning happening in London, but the whole rise of the city, the rise of transportation, modern modes of transportation, the trains, the airplane, the car, electricity going out to the rural areas in the country, designers finding appliances or creating appliances that could be electrified. This is by Van Nessen. It is a lamp. It's primarily aluminum, but it also has a bit of bakelite, and then there's a glass shade at the time. And Van Nessen was very interested in machine shapes, as you can see, and the replication of machine shapes. And of course, this is something that mass production really enabled, was the quick replication of standardized parts, standardized shapes. So he took these very geometric shapes and stacked them up to create this lamp, and he was playing with lighting effects, ways of diffusing light. The whole notion of selling modernity, selling these new products, selling these new materials, selling these new technologies was celebrated in 1934 at the Museum of Modern Art in their Machine Age exhibition. And as you can see here in this photo and the next photo, you can see a lot of kitchen appliances here, but what they all have in common is that they are made of modern materials, and they are devoid of any ornamentation. They are all made using geometric forms. And what inspired those geometric forms? They wanted their forms, again, to look new, to look fresh. And again, when I was talking earlier about what inspiration does a designer use often when they are creating new products, what do they look to? In this case, they're looking to the machine to celebrate the machine aesthetic. The machines symbolize modernity. And here you have springs, propellers, ball bearings, all parts of our modern life. Another designer, engineer turned designer, and a number of these designers actually started as engineers or started in another field and then migrated into design as they saw the opportunities, industrial design, was Warren MacArthur. And he was the first to really come up with the idea of modular metal furniture. Bent tubular steel had already been in production at this time, inspired by the Tonnet's bent wood furniture. But what MacArthur did is that he made this furniture out of aluminum parts. Aluminum cannot be welded, so he found ways to have these metal threaded parts where he could assemble modular parts. And in a few years' time, he already had 6,000 designs, furniture designs. What was also, of course, new at this time and symbolized modernism and the future was train travel and all the new modes of transportation. Designers at this time, the train companies, in this case, the Pennsylvania Railroad, wanted to attract customers, wanted people to travel by trains, and so they enlisted the designer, in this case Raymond Loewy, to really sort of rejuvenate, renovate the train, do a lot of styling, renovate the interiors, and to really help sell modernity, train ride, transportation, but also I want to call your attention to this very aerodynamic form, because aerodynamic and streamlining are also words that are associated with this time period and selling modernity. And streamlining really was a term that was used in the 19th century. It was inspired by observations of nature and hydrologists wanting to find ways to reduce drag on ships and other objects that would move through space. And so that's when they came up with these really beautiful teardrop shaped forms that were used, sort of appropriated in a lot of modern design. A good example of that is this wonderful motor. Again, I was so delighted when George opened his closets to us, and we saw this because how appropriate to have a streamlined design motor for a boat. It also extended streamlining to this beautiful meat slicer, which is sculpted, and it's cast aluminum, and again, it's a very beautiful use of the material. And as a curator, when I'm evaluating works for the collection, we often take into consideration the material that's being used, and is it appropriate for the design, for the form that is being used for. And I just think this is an absolutely beautiful sculpture. I'd love to have it on my counter. I'd make room for it. What is also, I think, very appropriate about this form is that there are not a lot of crevices for the meat and to get stuck into. So again, taking into account use, form. This is a great example of form follows function. This aluminum follows the important functional components of this piece, and is a beautiful unifying material and aesthetic. And this, to give it this beautiful lustrous aesthetic, which is also something that aluminum was prized for. Also at this time was the whole idea of entertainment, music, portability. Of course, it's something that we're very familiar with today, but it is something that has started long before our times. This lovely phonograph made of aluminum. The interior is lined with a red velvet to give it a particular glamour. But this was by a designer named John Vassos, who worked for RCA Victor for quite a while, and he would work very closely with the engineers and working with them, and then designing ways to make the parts more unified with the overall aesthetic of the phonograph. And then the other material was really the chromium plate. It's a finishing process. Of course, silver was super expensive, but how to find ways to mass produce your products so that they are available to the masses. At the time, this wonderful cocktail set was made. It was a few years after Prohibition was repealed, and it was, of course, also the rise of the skyscraper and the modern city. And talking about another source of inspiration for designers, it was really the modern city and the skyscraper and the skyline. And what better place to really underscore that was New York City, which was a real magnet for people at the time. This cocktail service was intended to sort of mimic the New York skyline. Chromium plate, it's a very thin layer of chromium over, I think it was a brass body, but the sheen, the reflective quality of it symbolized, again, this exuberance and optimism associated with the modern world. And it's also, at this time, once Prohibition was repealed, you can imagine how people were just crazy for cocktails and bar culture. And again, like the other products I mentioned of the aluminum products and home entertaining, of course, entertaining at home, this was ideal for it. And also at this time, this wonderful chromium-plated pitcher by Peter Muller-Monk that really celebrates the Normandy cruise ship that crossed the ocean. And France, it was a French cruise liner, and France commissioned their best designers, their best manufacturers to design the interiors. It was the most luxurious way of traveling. But again, this teardrop shape of this picture mimics the prow of a steamship. And of course, when I look at a lot of this styling as a curator, I often think, do we really need a teapot that looks like it's going to race off the table, or cups and saucers? But again, it was really very much about styling and the modern interior. The other material I mentioned was plastic. And plastic had been invented, the first plastic was invented in the 19th century, and it was celluloid. Unlike aluminum, which was more of an intellectual exercise initially, plastics came into being for specific purposes. The initial celluloid commission, it was actually a competition, was to design billiard balls, to replace ivory billiard balls with a synthetic plastic. And then in 1907, 1909, a man named Bakelin devised came up with a formula for Bakelite, which is really enabled the molding of plastics. It's a fluid material that when baked becomes a hard material. And it again lent itself to a plethora of new products and redesign of existing products. So here in this table lamp, you see a combination of the Bakelite with aluminum. That was by Polaroid. The company Polaroid, of course, was looking for new ways of marketing their products and new forms for their products to make them desirable. Walter Darwin Teague was the designer of this Kodak camera, which was very small and affordable to the masses, and again, very, very portable. Radios, as I said, George Kravis started by collecting radios, and we have a wonderful range of radios. These next few are made of Bakelite, and they are responding to what's happening in the world. Of course, this one by Raymond Loewy is celebrating what radios do, and that radios allowed us to connect with the rest of the world. And this globe, celebrating the world, also has the 7 continents on it, and was a wonderful way of celebrating international communications. Another wonderful example by the British designer Wells Coates, again out of Bakelite. And what form do you make it? This radio really celebrates the shape of the speaker. It's also in this wonderful green, sort of sage green, which was a popular color used in interiors at the time. So again, finding ways for it to blend in the interiors. And here, this other radio, the 66 radio, again, this time taking inspiration from the skyscraper. So the verticality, the vertical striping in it, the vertical ridges, again, the moldability, the molding capabilities of plastic lent itself to many, many different forms and shapes and textures. The Patriot radio by Norman Bell Geddes, made in 1940, was a wonderful way of using this new material, celebrating the United States during the time period, and of course the red, white, and blue coloring, but also the stripes evoked by the American flag. Again, it was at the onset of World War II, and celebrating patriotism. A few decades later, then, just to show you how fine plastic can become, this wonderful television by a couple Italian designers, and how crisp, you see the corners of it, and it just becomes like a beautiful, minimal sculpture that could be easily incorporated into an interior. When you turn on the television, then you can see the screen, the black and white screen behind it. But it's just another beautiful example of new ways of using the technology. Again, plastic being a moldable material, many designers were striving to come up with a way to make furniture out of one continuous piece of a material. This was designed by Werner Panton in 1959. And again, it's about simplifying the production process. So if you remember Tonnet, he had already simplified the furniture, the number of components for furniture. But Panton has pushed it even further to this one gesture. Like a lot of these firms, these companies at the time, people were looking for products that would really help brand them and what they stood for. This chair by Alexander Gerard was part of a much larger commission by Braniff International Airways to give the company a whole new facelift. And he designed everything from the logo to the furniture to parts of the aircraft to also the interiors of the terminal. And this chair, making use of aluminum legs, some of the new foams that were coming into the market at the time, and this wonderful upholstery by Noel. It's a Herman Miller chair, but it really shows how designers are being used at this time, and the role of the role of the profession of the industrial designer really paralleled this time period that I'm talking about as well. So it's really, things are happening on many fronts in the United States at the time to really transform this into a brand new culture. This chair I just want to show, it's an Italian chair made in the late 1960s, but like the Alexander Gerard's chair that we just saw, which was emphasizing comfort, luxury, and becoming calm before your flight. This very casual chair that really sort of was inspired by a lap, and thinking about someone reclining in a lap, really symbolized the whole sort of informality that was very much part of our culture in the late 1960s and 70s. And why I think this is so fascinating is that there are no internal armatures. This is completely foam now. So it's not the metal armatures, but the Italian manufacturers were very inspired by the mattress industry. In the mattress industry, they were starting to experiment with different foams, varying the densities in the foam, and the Italians were finding ways to incorporate it into furniture production, because it's very hard. How do you start to put wooden legs onto a piece of foam or metal legs onto a piece of foam, which was a real challenge. The Australian designer Mark Newsome did this very well in this sort of biomorphic chair that he designed in the late 80s, and it was inspired very much by nature, by also the aerocraft industry, using the forms, but it is upholstered with a neoprene that is used for wetsuits. So again, designers looking for new materials, finding appropriate applications. But again, using the foam interior, this type of foam, impregnated foam, was very, it allowed the manufacturers to really sort of embed the armature of the chair into the foam. And just one last piece in the plastic section is fast forward to this wonderful garment by the Japanese designer Issey Miyake, who throughout his career has revisited the idea of recycling and also how to make a garment out of one cloth. And so this is his sort of rejuvenate, recycle collection. The polyester, which is a plastic, was made out of PET, recycled plastic bottles. And then he worked with a computer designer to come up with this garment that is like origami. So when you open it, it's three-dimensional, but when you collapse it is this wonderful two-dimensional shape. Glass is a material. It's one of the oldest materials human beings have been making. And it's still today and is undergoing so many transformations. In 1915, Corning Glassworks came up with a type of glass, oven-proof glass, which they termed Pyrex. And it's still today, I think it's what many people, the way that many people know Corning. But they have innovated so many different types of glass. And this is an example. These are the Pyrex ware that they innovated in 1915. Glass, this is a chair by Louis Deria that it was designed for the Pittsburgh Plate Glass Company for the 1939 World's Fair. Of course, World's Fairs are moments for countries to show off their manufacturing prowess and ingenuity. 6 of these were made for the World's Fair, and it is slumped glass. Now, I don't know about you, but I would sit in a glass chair with a lot of trepidations. This didn't really develop much beyond this at the time. There were the 6 pieces made, but it was a wonderful way to experiment with this new material. About 4 decades later, this wonderful chair, glass chair, was made by a Japanese designer, Shiro Kuramada. Here he takes these very rigid, unlike this sort of curved organic chair form. He made this very rigid chair form out of sheets of glass. But this time, today, there were some super duper glues that he was able to employ to make this chair, which again, I'm delighted this is in the museum's collection so that we can document some of these major innovations in materials. To jump forward to some of the latest innovations in glass, which some people are saying the 21st century is the age of glass, and we are certainly seeing it on a lot of our computer products today, our interactive products today. But this is willow glass that Corning has developed, and they are finding all types of applications for it. It's being used in they are looking to use it for automobiles, windshields, windows, entire interiors, as home interiors. As we start to move, as this size interactive glass starts to expand to fill entire rooms, I think it's not too far off in the future where we're going to be seeing a lot of glass used in our interiors. And in fact, when I look at this, I can just imagine maybe being able to, if this were made of flexible glass, like we're saying, maybe we could, because we already know that the keyboard is just completely flat, that, and we just need to tap it, that we could perhaps roll up our computers or our smartphones, whatever, in the future and just put them in our purse or our pockets. A material, silicon. It's not something that a lot of people talk about, but it is really, in terms of revolutionizing the last quarter of the 20th century in our life today, was the material silicon. And silicon is one of the most abundant materials in the world. It starts as sand. And this came about during the space age, which was a very, very important moment that spawned a lot of ingenuity, research. The government supported a lot of research in this country. There was a lot of competition, but the space age and getting a rocket into outer space could never have happened without the microchip. The microchip was invented in 1958 as a result of the invention of the transistor, and it's when we could really reduce information to the binary code, either on or off, ones and zeros. So all text, all images, all numbers could be reduced to just electrical codes. And so designers started creating ways to create this microchip that could be embedded in all of our many of our products going forward. What's also fascinating at this time, and I remember in the early 1980s when I was focusing on this whole topic, is that we started to grow materials now. Silicon, as you can see here, these large ingots to your left, can be quite large. They are grown as crystals. What's really important is that they be as perfect as possible. They are grown in highly sterile environments, fab rooms. They are then cut into very thin layers onto which are etched these little microchips. And just to give you an idea how complex these microchips is, this is from an Intel chip from 1989. This is like, engineers would laugh at this today, but these are just an example of the circuits. This is taking design, industrial design, to another leap forward. In fact, it is so complicated, it is impossible for designers to actually hand design these chips today that they need a computer to design them. And so these chips are all about what they symbolize and are pushing forward on are our values of speed, optimization, and now miniaturization. What those chips enabled us to do, and I just want to underscore this for you, is that enabled us to take these earlier appliances of ours, and this being an early typewriter, it took these gears and mechanisms which were all interconnected and basically eliminated them and replaced them with electric currents, just that we could pass information. So what does that do in terms of products? It means that products no longer have to follow form follows function, like that meat slicer I was talking about, or this, if we were to put a case around it, you can envision what the shape would be. But now things are up for grabs. This is by an Italian designer, Mario Bellini, this calculator from 1972. And he designed, it still looks, has some similarities to earlier calculators, but the rubber skin is a much more playful skin. He's playing with new materials. And when you type the buttons, there's still a little bit of a click, but it's this wonderfully seductive material, almost like skin, almost like nipples when you touch them. But every year, these designers now, and this was for Olivetti, were racing to keep up with these new changes in computer technology and coming up with new forms. In 2007 was the introduction of the first iPhone. Which I suppose, looking at the age group in here, I'm sure all of you remember. And this was absolutely transformative. And it is the multi-purpose tool for just about, for so many people in the world today. And if you can imagine how it has really reduced so much of these earlier products into something this size, that you can imagine even with today's apps, not in the 2007 version, but today's version, all the hundreds of apps. You can put the cameras that we were looking in, you could put the flashlights, you could put radios in here, you could put your telephones in here, you could put those on and on and on. And it's just this marvelous tool of the 21st century. And even just starting to think about the way we start to interact with our products today, this is all about a different type of gesture than even these earlier products that we've been looking at. What I'm so encouraged about by a lot of products today, and I always feel every designer I know is a very optimistic person, and why is that? Because design is so much about finding solutions to problems, to making things better, to improving things. And we are starting to see now more and more products that are addressing some of the real needs in the world. This one laptop per child, developed by Yves Behar several years ago, it's basically a portable classroom that children or people in developing countries can use to connect with themselves and with the rest of the world. Another beautiful example is this portable LED light developed by Olafur Eliasson, and it, during the daytime, this light that is in the shape of a sun, talking about inspiration for products, or a sunflower. During the daytime, this lamp, it's solar powered, so it grabs the sun's energy and it fuels the LED light. In many parts of the world, and it's very affordable. In fact, if you buy this, one is contributed at a very, very low cost to people in the developing world. And in fact, this was designed to really address a really important and a critical problem in many parts of the world where they still don't have electricity, and that is kerosene lamps, which can be very dangerous if they fall over. They can be creating fires. If you inhale the fumes, it can cause a lot of diseases. So this is really a very beautiful solution. And then the last technology I just want to touch on in a couple of minutes is 3D printing technology. And here we have this, one of the first chairs ever created by 3D printing by the French designer Patrick Jouin. And I think many of you here are familiar with 3D printing, but what it does, it allows us, in a nutshell, it allows us to customize production. It allows us to to design something by hand, a drawing, and it's interpreted by the computer, and it bypasses the traditional manufacturing system, factory system. And you go right to printing that product in a particular chosen type of material. There is no waste to this designing. So again, addressing issues of sustainability. There's a lot of positive aspects about it. It's really very much in its nascent stages. But what I also like about it is that there's not necessarily a one-size-fits-all, like a lot of the products I've shown you thus far this evening. But if we were just to change a couple parts of the computer code for this chair, for instance, we could make it a much taller chair. We could make it a much shorter chair. This chair, what's also wonderful about 3D technology is it allows us to make forms that are either impossible or just insanely impossible, or just something you would not do in another material. I cannot see sitting down and carving this chair. You cannot injection mold plastic, you cannot get it out of the mold. So 3D printing is ideal for this. Patrick Jouin was inspired by blades of grass, how they would grow, hit a surface, bend and twist, and when you can look at this chair very quickly, you'll see some really beautiful turns that are not necessarily ones that one would naturally draw, but it has inspired a lot of new forms. Again, addressing critical needs. Wheelchairs are a really important design problem to address. They are used by many people in our society. Some people are in a wheelchair for all of their waking hours. Others use it temporarily, but there's a lot of work to be done in wheelchairs. And one of the special needs is to customize wheelchairs so that they fit the user a lot better. Now, you know that again, this is where I think 3D printing has a real future, because this chair, this 3D printed chair, which is a prototype at the moment, it's the Go wheelchair, but the seat is customized to the particular user, and the user is measured, and then all those dimensions are it's all computer driven and printed for that particular user. Also, it's hard to see in this image, but the wheels actually have these little nibbles on them, nubbies on them, and you have special gloves that you can use, because the wheels are treated more as handles, because again, it often becomes a very tiring, challenging part of mobilizing oneself. Another really beautiful example of the application of 3D printing and customizing products is this scoliosis brace. Scoliosis is something that affects a lot of people. Sometimes it's treated by surgery. Oftentimes, most often the the person who has it, if they want some aid, they have a brace. Often the braces are rather uncomfortable. They are not always sized to them, but they're actually fairly unwieldy. They're fairly thick, and they can be an embarrassment for the user. So because they're thick and they might show through the clothing. So this wonderful scoliosis brace, which is being produced, and I have to show you the video for it, because you'll see, as a design museum, we focus a lot on process, and you'll see here how it is customized, or how it is designed, and how the designers, as they are customizing it for the wearer, as they are removing materials to make it lighter weight, so it is more comfortable, it's more malleable, it moves with the wear. That's the process that they're going through now, studying it, customizing it towards the wearer. At the end, once this model, computer-generated model, is finished, then that is connected to a printer and it is printed for the user. It also embedded in there are microchips, so it is giving information back to the doctor to learn ways to further hone and perfect this brace for the user. Again, a lot of applications. The customization that comes and the individuality that comes with 3D printing is something that I'm really looking forward to seeing develop. And the last image I'm just going to show you is this of wearable technology. Again, finding ways to embed the technology into our garments, finding ways to make materials respond to behaviors. We can actually now put behaviors, design behaviors into materials. As I said, when I saw the silicon and being grown and controlling the growth of materials, it was really a transitional moment for what was to come in the future. This balaclava is worn by people in cold climates to warm their head, their face, and also their breath so that their lungs don't get so cold. But actually with embedded technology, we have the opportunity now to heat the yarns, to heat the material so that by the time the air gets to our lungs, it doesn't freeze our lungs. So I'm happy to take questions, but I just want to end by saying that I'm very optimistic about a lot of the designs that has happened, what we're going to be seeing in the near future. But a lot of it is very much thanks to not only the creativity of designers, but really the merging of scientific inquiry, technology, art, and really going forward much more the user. So thank you for that, and I think we have a few minutes. I'd be very happy to take questions.
Does anyone have a question? Can you raise your hand?
Hi.
Hi.
I'm not sure quite how to phrase this, but I think you just showed me, and I think us, how the acceleration of the Industrial Revolution all the way up to the digital age was reflected in the material mastery and the processes of these objects that correlated with the growth of these super cities, so that objects became, in a way, less personal. And I think the digital age, especially with, how did you phrase it, miniaturization and computer, assisted design, has created a situation where, objects have gotten smaller and lighter, and especially these personal computers of ours have become almost less physical, less oriented maybe to the cognitive sense, but not so much to the physical sense or any other sense. And so looking at the Olivetti stuff from the 60s and 70s, it seemed like there was so much more physical and tactile, and they engaged different senses or senses differently than software and glass are meant to engage. So my question to you is, what happened? Beyond just the acceleration of technologies and these new materials and the mastery of production, what happened to the designer's intent to engage ulterior senses or all of the senses with these objects?
That's a great question, and it's something that we, as the curators, we talk about. It's actually a topic that we are focusing on exhibitions. We've started introducing some of the other senses into our exhibitions here at the museum, because you're absolutely right. Our other senses are such important sources of information for us and ways of exploring and experiencing the world and getting joy from the world. And I think that as we become, and as well as designers, manufacturers, become more aware of how important the senses are, that we are going to see that impacting some of the designs that we have, and whether it be the materials that are used. I've just showed you materials that came onto the scene. If I were to grasp materials over since the beginning of human beings, it would be pretty flat. And all of a sudden there was a spike just at this very end. In fact, it's something I'd love to do at some point, just graph that. What else hasn't been innovative? But it doesn't mean that we have to come up with new materials to solve what to address what you're talking about. I just think it's the ingenuity. I think it's the understanding of, we know intuitively when we touch something nice and furry, it's nice and furry. It makes us feel good. Or the width of that chair by Gerard, that it was more commodious and comfortable, or the foams give us more comfortable. But I think that you're right, we have lost a lot of this sort of physicality with our products today, but I think this is why we are seeing in the world of textiles, for instance, a much more interest in textiles. Look at our textile exhibition upstairs in Scraps. Much more, there's a lot of experimentation in textiles, a lot more variation in textiles. There will be, embedding chips can also bring a lot of responsive qualities to materials to us, so that they are going to be sensing our temperatures more, the room temperatures more, sounds more, as we're learning more about the brain in this century, a lot more about the brain and how we respond, the cognitive response to. It's going to impact maybe colors we use places, or textures of surfaces of buildings, even guiding people with disabilities into spaces, or even our streetscapes. How do people maneuver our streetscapes, giving more texture to them as people navigate our cities and life. So I'm actually very encouraged. A lot more people, I can't say a lot more, a lot of people now you hear craft, like return to craft. More people are knitting now. It's just, people are yearning for exactly what you're talking about. And I think they're finding wonderful ways to marry the hand with machines. So, and you'll be seeing this on a lot of our shows. So you have to come back to Cooper Hewitt, because a lot of this is has been addressed, but we're really addressing it in bigger ways.
I wanted to share something that I found very, very exciting, because once a year in New York they have this very large 3D printing expo at Jacob Javits, and it's great to bring your kids. So not only what you're talking about, but in the fact that people are designing with the environment and energy and all these other efficient ways. But I was really touched by the medical use of 3D printing for when a child, and they even showed a video, a child had lost his hand, and he's a middle schooler, and he goes into school and has this device on, and all the kids back away from him like it's weird, and they don't talk to him. But then there was this ingenious 3D designer who made that device look like an action figure hand with
Something really cool, right?
really cool with bright neon colors and hot orange and then it showed the video of him going to class and everybody just circled around him. I thought that was just really
That's
sweet.
a really nice example of this customization of 3D print, a lot that's enabled by 3D printing and this individuality. And, there could easily come a day when we all have 3D printers at home and can do things like that. That's a great example. Thank you.
So I think we have time for one more question if there's somebody that has one. Anybody? Okay.
After this survey of 100 years or 150 years of development of materials, do you have any thoughts on the future, particularly of plastics and of addressing issues like environmentalism?
Yes, that's something that we are always, again, in terms of the, again, I'm very encouraged in that area because plastics today are much more sophisticated plastics than they were like when Earl Tupper, S. Tupper was making Tupperware. In fact, some of that early plastic started to liquefy over time. So plastics, it's always kind of struck me that a material that can actually last for a very, very long time was a very, people were using it for disposable things. It just didn't seem to make sense to me. But that said, I'm very encouraged here by all the attempts at recycling and the thoughts of sustainability in materials today. I think we have a lot of ingenuity to address these problems, to try to solve them. We need to just bring more people on board to find systematic ways to make that happen when it comes time to recycling. But I do think that plastics has a lot of wonderful, it's so beneficial for so many use. Let's find a good way to use it. But I do think that 3D printing, we're now able to print metal, we're able to print paper, we're able to print so many different types of materials that might actually, take some of the space that was previously occupied by plastics. We'll see. Thank you very much for coming. A lot of these types of products that I showed tonight will be in our forthcoming Jazz Age American Style in the 1920s exhibition, which opens to the public on April 7th. Thank you very much.